Okay, we're going to start off today graphing the equation of circles. And actually, the first thing we're going to do is we're going to flip over and we're going to get a graphing grid on here. So let's go over to my graphing grid here. And I don't necessarily need that. So let's just start with a circle of, and hopefully it lets me select what I want to select here. Well, maybe it will. There it goes. Okay. Let's make a circle of radius 2. Just because we needed to have some radius. So let me make a few points here. So we've got, okay, and I'm actually just going to cheat just a little bit. I'm going to make a little circle. Do my best to make the center at the origin. And I did not do a great job. So let me actually just click and drag it, and we may have to just use our imaginations to some degree here. Click. Oh, let's drag this guy. Okay, so we're gonna pretend that circle has exactly a radius of 2. So let me just pick a point on the circle. This is a good point as any. Let me draw the radius out here. My pen is not happy with me right now. Okay, so that's not a good radius. Okay. So let's pretend that that's my radius. My pen's freaking out just a little bit. We said that this circle has a radius of 2. We don't know necessarily the coordinates here. They're just some xy coordinate. But if we drop down a perpendicular and make this a right triangle, okay, we know a little something because we know Pythagorean's theorem, right? So we know that the length of the sides squared, or the sum of the length of the sides squared, are going to equal the radius squared. So let's just write it out as you typically see it. A squared plus b squared equals c squared. And let's think about what we know. Well, obviously our hypotenuse is our radius, which in this case is 2, so we have 2 squared. Now we really don't know these, since I just picked a random point, I don't know this distance, this distance here. Let's just call it some random x distance. And let's, by the same token, just call this side just some random y distance. So then we're going to plug those in. So we just have x squared plus y squared equal 2 squared. Okay, and let's evaluate just a little bit. So we know that x squared plus y squared is equal to 4. And this right here is the kind of general formula for the equation of a circle that's centered at the origin. Now, it is specific to having our center at an origin, but in this particular section, that's all we're going to be dealing with. So that's we'll cover different centers at a different time. So, well, let me regain control of my pen here. I'm starting to get a little recalcitrant. So in general, no matter what the radius is, we could write x squared plus y squared is equal to the radius squared. You notice our radius was 2. 2 squared is 4. So that is just the general equation of a circle centered at the origin. So let's go ahead and let's just graph a couple examples so maybe you can get the feel for how this works. Let me clear my graphing grid here. Okay, that looks pretty good. So let's say our example, we wanted to graph this equation, and let's say it was x squared plus y squared equals 16 is going to be too big. Let's make it 9. So first we got to look, is this the equation of a circle? Yeah, it is. It fits the pattern. X squared plus y squared equals the radius squared. So 9 is r squared, which means we take the square root of 9, we should get 3, which is our radius. Here's how I go about making my circle then. So if this is 2 and then 4 is there, 3 must be right in the middle. Again, my pen's being a little recalcitrant. Might just have to go to using my mouse. So 3 is right here. Right, by the same token, we'd have 3 on the y-axis up here somewhere. Negative 3 is here. And then on the y-axis, I believe negative 3 would be right here. Okay, so, gosh, I don't know why it's freaking out so bad. All I really have to do is, if I have 4 points there, you know, at my intercept, so to speak, then I'm just connecting. I'm going from intercept to intercept, connecting them with a smooth arc, as smooth as I can. Whoa, again, I'm using kind of I'm not using the best tools here. So I'm not going to get a great circle. Hopefully, using an actual pencil, you're a little better than what I am. I might. Anywho, it's going to be wobbly. I should have just used my circle tool, but I wanted to try to hand draw it. Anyway, that's a circle. Just pretend it has a constant radius. Circle. You may have to identify the intercepts. If that's the case, of course, I mean, it's pretty easy to see in this case. We have x-intercepts at 3 and negative 3, and we have y-intercepts at 3 and negative 3. Okay, so it's pretty easy to tell from the graph there. One last example before we go, because I know that if I don't at least mention this, I think it's going to confuse some people. So let me clear my graph here. And in fact, if I just do this, I believe I can clear it. And let's do one more example. Let's say we wanted to graph let's say 16. I'm gonna have to actually move my my words here. We're gonna graph 16 minus x squared equals y squared. Well, at first you're looking at this and you're thinking to yourself, well, this doesn't quite fit the pattern. I don't understand. This does not appear to be the equation of a circle. But look what happens. If we would add x squared to either side, we'd end up with 16 equals x squared plus y squared. And now we do have the equation of a circle. And we can see that if we have 16 over there, that means 16 is r squared. Again, that's r squared. So r then would actually be 4. Let me clear up some of this stuff here. So my r is 4. And then we're just going to graph it just like we did before. So I'm making points at 4, negative 4, negative 4 down there, which is almost off my screen. Just somewhere in there. And then you would, again, connect these with smooth arcs. I'm not going to bother doing that. I'm just going to cheat and use my circle tool, although I guess you guys don't have a circle tool. But you can use your pencil probably a little bit better than I can use this pen. It's been acting up on me. Again, if you want to identify the intercepts, we're really just looking where does it cross the y-axis on the graph. Now, my circle tool is not exact. I can't exactly put at the origin. If I were exact, we'd see that on the x-axis, it would cross exactly at 4 over here on the x-axis. It would cross exactly at negative 4 over here. Exactly at 4 on the y-axis, and also negative 4. So you notice that when we have a circle at the origin, it's going to have 2 x-intercepts, 2 y-intercepts. And they're pretty symmetric about each axis too. All right, so that's kind of the spiel on graphing circles. If they're centered at the origin, it's pretty straightforward.